Okay. Hi everyone. We the group of group 2 and our team members are Anirudh, Jisha, Pranati, Rutu, Venkat Naresh. So we have decided on the topic of anomaly detection of financial data. So we are going to discuss about interaction of data analysis and modeling, data cleaning and validation procedures, correlation analysis and grouping, distribution visualization and time series analysis, comparative analysis of lead ownership trends, analyzing the impact of customer experience, statistical analysis and model evaluation, and last about conclusion. So here we go. This presentation is utilizes a training set of 60 entries and the test of 40 entries to conduct through data cleaning, validation, and advanced analytics focusing on financial and operational metrics like IRR and reduction. The goal is to uncover correlation trends and anomalies to inform strategic decisions aimed at enhancing business performance and investment outcomes. And coming to the problem description, participants are tasked with creating a predictive model for anomaly detection in virtual desktop infrastructure known as VDI financial data. They must pre-process the dataset handling missing values, encode categorize variables, and explore feature relationships. The goal is to classify samples in the test as a normal or anomalous, aiming for high performance measured by micro F1 score. And coming to the train data, so right side we can see the data, and this data set compares 60 observations and 25 featuring detailing financial and operational metrics across companies. Key indicators such as IRR, W average, reduction, OPW, and categorical variables like company and fund are included. Facilitating predictive modeling and anomaly detection task, visualizing analysis through sector plots, reveal data distribution, aiding in identifying patterns and trends in deeper analytical insights. Coming to the test data, and this data contains of 40 entries and 24 columns of mixed categorical and numerical data suitable for predictive modeling and anomaly detection tasks. Train DF comprises 60 entries and 25 columns featuring timestamps, categorical variables, numerical metrics, and minimal missings, data in lead on and lead on old, offering efficiency for analytical exploration and modeling training. And then next will be continued by Anirudh.
Yeah, welcome to my presentation, and I'm going to start with a statistical summary of the training data using describe function. And this function provides key statistics for numerical columns in training DF dataset. Sorry, train underscore DF dataset. And there are 60 entries for each column except the for lead on with 59 and lead on old with 31. The IRR column has a mean of approximately 0.185 with a minimum of minus 0.313 and a maximum of 1.022. The W underscore average column ranges from 1.55 to 3.9, and the reduction column ranges from minus 0.8 to 1. And these statistics helps us understand the distribution and identify potential outliers for strengthening the data set. And while coming to anomaly label distribution, and we are using the value underscore counts method, and we'll be looking at the distribution of anomaly label column in the train underscore df dataset. The binary column indicates anomalies and non-anomalies 0 with 41 non-anomalies and 19 anomalies. We used the value underscore counts method to count the concurrences of 0 and 1 in specific columns. By storing these counts in a dictionary, we can clearly see the distribution of these labels, which is crucial for understanding the dataset and guiding further analysis. And now we can see the data cleaning overview. Uh, Now let's discuss the data cleaning process. Our data frame consists of 60 entries and 25 columns, including various data types such as date, time, object, float, 64, and int 64. The time column contains date time values, and some column have missing values indicated by non-null counts below 60. The data frame is compact using 11.8 KB of memory and another similar data frame with 40 entries using about 7.6 KB. Understanding the composition and memory usage of our data frame is essential for efficient data processing. And now coming to handling missing values and data types, mm, we address most columns have zero missing values, but lead underscore own has one missing value and lead underscore own underscore old has 29 missing values. Depending on depending on the analysis goals, we can use techniques like imputation or removing rows, columns with missing values. In the df underscore clean data frame, the time column is converted to datetime format for time-based analysis. And we standardize column names by removing spaces and check data types to ensure consistent naming, which aids in data manipulation. And while coming to, oh, sorry. Okay. Now let's move on to outlier handling and data validation. We removed rows here where IRR values are below a threshold, considering only positive values as valid. This helps filter out invalid data points and handles outliers effectively. We validated the anomaly underscore label column using isin method to ensure it only contains valid values 0 and 1. Descriptive statistics from describe indicate no missing values, which helps in explanatory data analysis. And now coming on to kernel density estimation (KDE) of numerical columns. And finally, we have the kernel density estimation plots for numerical columns. These plots provide a visual representation of the probability density function for each variable. They show the distribution of values on x-axis and the corresponding density on the y-axis. As we can see, each curve represents different numerical columns such as IRR, W underscore average, reduction, and others. Higher peaks indicates region of higher density, while wider curves suggest a broader range of values. And KDE plots help us understand the shape and spread of data distributions, aiding in identifying potential pattern of anomalies. Now my teammate will continue.
Sure. So, as Anirudh and Pranati has discussed about various things, let's move on to some more presentation slides such as pair plot, correlation analysis, uh, grouping and aggregation, mean versus median, and data visualization, correlation analysis using heat map. Coming to pair plot of numerical values, the pair plot provides a comprehensive visual overview of relationship between numerical variables in dataset. Each scatter plot cell shows comparisons while diagonal cells display individual histograms. This helps identify correlation patterns, trends, and outliners, aiding in exploratory data analysis. And then heat map of correlation matrix. We visualize the correlation matrix using a heat map with a cool warm color scheme, and we annotate values. This graphical representation highlights the strength and direction of pairwise correlations between numerical features, providing insights into relationships with data sets. Let's move on to the next slide. Grouping and aggregation. The data frame is grouped by company, calculating the mean and median IRR for each group. The analysis reveals financial performance variations with companies like F and P showing high IRRs, while H shows a notably lower average IRR, offering a dual perspective on IRR distribution. Then let's move on to the mean versus median. Yeah. The bar chart of mean versus median compresses the mean and the median, the mean in green and the median in red, IRR values across companies. It helps in understanding the central tendency of IRR within each company and highlights the difference on similarities between these two statistical measures, facilitating a straightforward comparison. Next, let's move on to the distribution visualization. In distribution visualization, the CDF plot visualizes the cumulative probability of observing IRR values. The x-axis shows IRR values and the y-axis displays cumulative probability. The curve illustrates the likelihood of encountering specific IRR values, providing a clear understanding of their overall distribution and relative frequencies. Let's move on to the next one. Correlation analysis using heat map. uh, Clustered correlation heat map it is. Numerical columns from DF cleaned are used to compute correlation matrix, visualized as a heat map. Warmer colors indicate positive correlations and cooler color indicates the negative correlations. This cluster heat map helps identify patterns and dependencies within the data, offering insight into its underlying structure. Following slides will be continued by Ritu, my teammate.
Yeah, this slide represents a bar chart analyzing the frequency of different companies' appearances in a dataset. Each bar represents a company with the height of the bar indicating how often that company appears. The x-axis lists company names like NP, MPS, INH, and Stomach, while the y-axis shows their frequencies. This visualization helps quickly identify which companies are more prevalent, making it easier to stop patterns or anomalies in the data distribution. Next slide, please. Yeah, this slide shows like the IRR trend with rolling mean and confidence interval. It visualizes the internal rate and of return IRR. The red line represents the rolling mean, smoothing out short-term fluctuations. The pink shaded area indicates the confidence interval around the rolling mean, showing the likely range of the true mean IRR. This helps understand the trend, spot anomalies, and assess IRR stability over time. Next slide, please. Yeah, this slide represents the distribution of IRR, internal rate of return across different companies and funds. A bar plot shows the average IRR for each company fund combination, with the bars color coded by fund type, MEF3 or like MEF4. This visualization helps compare IRR performance across various investment scenarios. Next slide, please. This slide shows the average vision score for different fund types, MEF3 and MEF4, indicating a score of 0.1818 for MEF3 and 0.0000 for MEF4 to compare their performance. Next slide, please. This slide provides descriptive statistics and an ANOVA test for vision scores, showing no statistically significant difference between the vision scores of MEF3 and MEF4 funds. Next slide. This slide examines the correlation between reduction values and IRR, internal rate of return, aiming to identify patterns or trends in investment or performance based on the degree of reduction. Next slide, please. Yeah. This slide shows a joint plot of reduction versus IRR, indicating a moderate negative correlation between the two variables with a correlation coefficient of minus 0.356. Though the relationship is not statistically significant, p-value of 0.081. The next slides will be continued by my friend.
Yeah, now I'm going to discuss about KDI plots, prediction, and IRR. The reduction column's descriptive statistics reveals 25 data points with a mean of about 0.116 and a standard deviation of approximately 0.289. The data range from minus 0.85 to 0.75, with quartile values providing insights into the distribution, including a median of 0.15. The KDA plots for reduction and IRR depict their probability density functions, offering a smooth view of their distributions and indicating concentrated regions with higher peaks and less concentrated areas with lower or flatter regions. These plots help visualize the typical ranges and variability in reductions and IRR values within the dataset. And the pair plot of transform reduction versus IRR visually depicts the relationship between long transformated reduction values of IRR. Scatter plots shows data distribution and correlation trends, helping access how changes in long transform reduction values corresponded to IRR changes. On the reduction, this suggests no consistent linear relations at a site density for one variable to increase and the other decreases in a non-linear manner, particularly useful for non-linear relationships on ordinal data. Next slide. Trend in lead ownership over time. The lead ownership in trend over time plot shows lead ownership values across different months from February 2021 to January 2022, offering insights into the evolving patterns and in lead ownership over the specified time span. The trend changes in lead ownership over time bar plot visualize lead ownership changes across consecutive time periods with positive values indicating increase and negative values indicating decreases. Each bar corresponds to a specific time period, color coded with green bars for positive changes and red bars for negative changes, providing a clear understanding of growth or decline in lead ownership over time. Peak and valley in lead ownership. The peak and valley in lead ownership plot usually represents the in leader ownership over time using a stepped blue line. Green triangles mark peaks representing high points in ownership, while red inverse triangles denotes valleys indicating low points. This visualization effectively highlights significant changes and trends in lead ownership, aiding in pattern identification with the data. The smooth long-term trend in lead ownership confidence interval plots depicts the overall trajectory of lead ownership using a smooth trend line derived from a rolling average. This smooth line offers a clear view of underlying pattern on long-term changes in lead ownership. The shaded confidence interval around the trend line illustrates the range of likely lead ownership values, aiding in the interpretation of overall trends, direction, and magnitude. The stacked area chart illustrates the trend of average lead ownership over the time segmented by company, with each company's data represented by a color section stocked on the top of each other. The x-axis displays time in quarters, Q1 and Q2, etc., with the y-axis shows average lead ownership, making it easy to observe trends and changes in contribution across companies at a glance. This type of plot is useful for comparing the relative distribution of lead ownership between MEF3 and MEF4 over time, illustrating changes in contribution and the proportion of ownership attributed to each fund during different periods. The heat map we have described visualizes the average vision scores across different bins of IRR and average. The IRR bin on the y-axis on the x-axis represent the categorized ranges of investment return weighted average respectively. The color of intensity with the heat map indicates the magnitude of the average vision score, with darker shades representing the higher values. The highest average vision scores conversely many bins display a score of 0.00 indicating no data or a very long average vision scores for those IRR and average combinations. This visualization helps identity with IRR and average intervals associated with a higher or lower vision scores, providing insights into potential correlations of trends. Now our teammate will continue.
Yeah, coming to the impact of customer experience on IRR across various funds. Scatter plot to visualize the relationship between two variables, internal rate of return and the customer experience, while also incorporating the third variable fund as a view. Each data point on the plot represents a specific combination of IRR and the customer experience, and the points are colored based on the fund they belong to. This visualization allows for a simultaneous comparison of IRR and the customer experience across different funds, making it easier to identify any patterns or trends that may exist within or between the funds. The box plot compares the distribution of internal rate of return for different funds, especially MEF 3 and MEF 4. The box plot provides a visual summary of the IRR data, showing the median intra-quality range and any outliers. And by comparing the box plots for a MEF 3 and a MEF 4, one can access the differences in the central tendency, variability, and the presence of the outliers in their IRR distributions. This helps in understanding the spread and characteristics of IRR values across these two funds. Yeah, next slide. Yeah, coming to the distribution of internal rate of return for different funds. Segment performs several analysis on a data frame for a specific time period from January 1, 2021 to December 31st, 2021. First, it filters the data frame based on the specified time period and selects the relevant columns. IRW average, reduction, variation, option PW, KPS, bus international, FAOPT, DG transmission, deleted account, lead one world for descriptive statics and correlation analysis. Next, it calculates distributive statics such as count, mean, standard deviation, minimum, quartiles, and maximum for the selected columns using the described method. It also calculates the relation matrix among the selected columns and the anomaly label column using the corrective method. Finally, it visualizes the pair plot of this feature colored by the anomaly label, where the diagonal plots are kernel estimates of the distributions, and the off diagonal plots show the relationship between pair of features. This visualization is helpful in identifying any patterns or relations between the features and how they relate to the anomaly labels. Yeah, next slide. Coming to the time series plot. The time series plot you are describing shows three variables, IRR, WRG, and anomaly label, plotted over time from April 2021 to January 2022. W average of fluctuates around 0.6, suggesting stable average values. IRR shows more volatility with values ranging from -2.4 to 3.2, indicating significant changes over time. Anomaly label appears to be a binary or categorical variable with values jumping between -2.8 to 3.0, possibly indicating the presence of animals in the data. Coming to the enhanced correlation matrix heat map. The enhanced correlation matrix heat map, you have described visualization the strength and direction of relationships between variables. Here's a conscious explanation. Positive correlation, example IRR and W average 0.67 suggests that as the one variable increases, so does the other. Negative correlation, example vision and W average minus 0.12 indicate that as one variable increases, the other decreases. Strong correlations are closer to 1 or -1, showing a strong relationship. Values near 0 suggest a weak or no linear relationship between the variables. Conversely, variable like reduction and lead one show weaker correlation, around -0.3 and -0.2 respectively. Represented in shades of blue, indicating a negative relationship but not as strong as the positive correlation mentioned earlier. Overall, the heat map aids in the understanding the interrelations between the different features in the data set and can guide further analysis or model building by identifying potentially correlated variables. Yeah, next slide. Coming to the pairwise scatter plot matrix with the histogram diagonal. The provided data seems to present a set of variables, including W average, average value, IRR, interest rate of return, vision, possibly a binary indicator, OPTPW, optimal power, KPS, key performance indicators, and anomaly label, a label indicating normal or anomaly status. The pairwise scatter plot matrix with histogram diagonal visualizes the relationships and the distributions among these variables. This scatter plot shows the relationship between two variables, while the histograms on the diagonal represent the distribution of each individual variable. The hue encoding by the anomaly label allows for visualizing any patterns or clusters corresponding to normal or anomalous data points across the variables. Yeah, next slide. Yeah, coming to the statistical analysis and the model evaluation. The logistic regression model achieved an accuracy of 60%, indicating correct predictions for 60% of instances in the test set. However, its classification report and the confusion matrix precision and recall for class 1 were both 0, indicating the model did not identify any instances of class 1 correctly and missed all instances of this class. To enhance one moment. Yeah. To enhance model performance, potential strategies include balancing the data using techniques like overstreaming or class weights, exploring future engineering for better class differentiation, trying different models, fine-tuning hypermeters, and using alternative evaluation metrics like ROC, or F1 score, particularly crucial for handling imbalanced data and ensuring a model that performs all across all classes. Next slide. Yeah, in the confusion matrix, each row represents the true labels, actual classes in the test data, while each column represents the predicted labels, negative and n indicating the instance where the model actually predicted the instance where the model actually predicted class, and in this specific matrix, the cell at row 2, column 1 show false negatives, indicating instances where the true label was class 1, but the model predicted class 0. Lastly, the cell at row 1, column 2 represents false positives, signifying instances where the true label was class 0, but the model predicted class 1. Overall, the confusion matrix provides a clear visual representation of the model's performance in terms of correctly and incorrectly predicted classes. Yeah, next slide. Coming to the conclusion. The analysis of financial and operational metrics across diverse data sets has provided valuable insights and recommendations for improving business performance. By leveraging correlation analysis and the predictive modeling, critical relationships and anomalies were uncovered, offering guidance for proactive decision making. These insights will be instrumental in driving continuous monitoring and refinement, fostering sustained growth and competitiveness in dynamic business environments. Specifically focusing on anomaly detection in the financial data within VDI process, the goal involves developing a predictive model to classify data points as normal or anomalous. This entails preparing a handling missing values and encoding categorical variables to train a machine learning model. Evaluation will be based on the macro F1 score, ensuring a balanced approach that prioritizes both precision and recall to robust anomaly detection in financial data. Yeah, thank you. Thank you for all.